That's crazy.
Alright, so this video is going to be about Michael Phelps racing his 200-meter IM at the Olympic trials, and I'll be explaining the physics involved in this extremely interesting swim. So at the start of this clip, I have it paused. You can see how the swimmers start to line up at the starting blocks, and right now each swimmer contains a lot of potential energy that will be converted into kinetic energy the moment they all jump off the blocks into the water. Potential energy is exactly what it sounds like. It's the energy stored in an object that can be converted into kinetic energy. And I'll start the video, and you can see
I can't do it, you guys can.
as they jump off the blocks. I'll pause it right here. As they jump off the blocks, if you were to attach a ticker tape actually to Michael Phelps and look at the pattern the dots made on the sheet, you would see them spaced very close together at the beginning before he jumps, and then a lot farther apart as he jumps off, actually hits the water and starts to accelerate. This is because he's accelerating, and as you accelerate with the ticker tape, the dots begin to get farther and farther apart, which I think is extremely interesting. Okay, so let's rewind to the beginning again, and if you watch it start again, if you notice how the swimmers all leap off horizontally, and then they all dive into the water at about the same time. This is because gravity acts on all the swimmers the same and pulls them down. So their vertical acceleration is equal to gravity. So if you watch him in his race, you can actually calculate his force as he swims through the water, since Newton's second law states that you only need mass and acceleration to calculate force. So if I assume that during the middle of his race he's moving at a constant speed with zero acceleration, his forward force would also be zero, no matter what his mass is. Now, as he just went into his turn, you might have noticed how he pressed into the wall with his feet and bounced off. This is because Newton's third law states that every force must have an equal and opposite force. So as he presses into the wall with a certain force with his feet, the wall presses back with an equal and opposite force. You can see here he pushes off again and helps him propel him off the wall. So one of the last things that we're going to be talking about in this clip is how when you're swimming, you need to have friction against the water to propel yourself forward, which is good, but it's also bad because it hinders you from going forward as fast. That's going to be all for this video. Hope you enjoyed my physics commentary. Goodbye.